Okay, so going back, this was D, right? I did make a mistake. Y can't be 0. You're right. So I was thinking, hey, it's not under a square root, so it doesn't matter, right? But you're right, it's in the denominator, it can't be 0. Okay, and then let's take a look at that C. Thanks for catching that. Okay, C starts off this way. 11 over top of the square root of 5 plus 7. Okay, this one has adding and subtracting, so I am not able to do step 1 and step 2 like I normally did. I jump right to rationalizing the denominator. Okay, so my denominator is a binomial. It's a square root 5 plus a 7. So in order to get it to cancel, I need to times by a square root 5 minus a 7. Now, please be diligent, use brackets, because this is not a proper statement. This statement technically is only multiplying these two pieces in here, but you want it to multiply both, so make sure you do this. If that's what you're going to multiply on the bottom, then that's exactly what you're going to multiply on the top, because you got to keep it the same. This is called the conjugate. Okay? The conjugate is the exact same binomial with a different sign in the middle. Okay? Now, I'm going to multiply at the top first, and you'll just see what the answer is in the numerator. But then when I multiply out the denominator, you're going to see how it works so nice that it makes that square root go away. Okay, so in the numerator, you have a monomial getting times by a binomial. So that's 2 arrows. 1, 2. Okay? Now, is there a square root with this 11? There is, but it's hidden. It's just square root 1, which doesn't really matter, right? But if you're somebody that's thinking about how do I multiply these things together, and you need both pieces, then you can imagine that that is there. For now, 11 times square root 5 is just 11 square root 5. And then the 11 times by the negative 7 would be a minus 77. Okay, now on the bottom, I have a binomial times by a binomial. Okay, so I'm going to have 4 terms. Square root 5 times square root 5, what's that? Just 5, right? Or it's the square root of 25, and then you cross it off, and it's okay, it's 5. Okay? What is square root 5 times by a negative 7? Well, the negative 7 is not under the square root, so it does not actually get times by the 5, because the 5 is underneath. So they just get times by, like this, kind of, a negative 7 square root 5. Okay, but the whole goal was to get rid of the square root, so we still have one. But since you picked the conjugate, which has the opposite sign, but the exact same factor other than that, the next term you get will be exactly the same, only the opposite sign. So it will be a plus 7 square root 5. Then the square roots will cancel. Okay? And then the very last one will be 7 times by negative 7, so it's going to be a negative 49. Okay, these two middle terms should always cancel out if you picked your conjugate properly. And now what you really have is, I know it looks like it's one number, but you got to think of this. This is 5 minus 49. It's not, it doesn't look like difference of squares, but it really is. It's square root 5 squared minus 7 squared. So that's why those factors up there that were kind of like the difference of squares factors, get rid of your square roots. Now they're going to come down to single numbers. 5 minus 49 is negative 44. So the top stays the same, 11 square root 5 minus 77 over negative 44. Is that correct? Did I make a mistake? Yep, that looks good. Okay. Again, you can't do vertical reduction. You can't do any horizontal reduction only because there's no perfect square that fits into 5. But I can reduce if all my coefficients are divisible by the same thing. So anything that's not under the square root, 11, 77, 44, what are they all divisible by? 11, good. So 11 divided by 11 leaves me with a 1 square root 5, but I don't even need to show the 1 if I didn't want to. Okay, minus 77 divided by 7, or sorry, divided by 11 would be 7, and negative 44 divided by 11 would be a negative 4. Now, we usually don't leave denominators as negatives numbers. So you would times the negative up to the top, and when you do that, it distributes out. Okay? So you'd have a negative 5 plus a 7 over a 4. Okay, so when you pull that out, it just has to get distributed up onto the top. Oh, and what did I miss? My square root.